Okay, Assalamualaikum. Let's continue our chapter 4, normal distributions. So here we continue at checking for normality. So if you can see that there are 4 different ways to check the normality. The first one is histogram, Pearson index PI of skewness, outliers and other tests. So other tests consist of normal quantile plot, chi-square goodness of fit test, Kolmogorov Smikirov test, Lilliefors test. So in this chapter, we will cover only 3 things: histogram, Pearson index PI of skewness, and outliers. Okay, so let's take a look on the first one, which is a histogram. So let's say you have this example. A survey of 18 high technology firms show the number of days inventory they had on hand. Determine if the data are approximately distributed, normally distributed. So here we have 18 data starting from 5 until 158. So the first one is we need to construct a histogram. So when you construct a histogram, you can see that there are 7 classes. The first class starts from 5 until 29, and then 30 until 54 until 155 until 179. Okay, so when you draw a histogram, you can see that your shape in bell shape like this. Okay, and then after that, for method 2, you need to check for skewness. So here the first one is you need to find the mean. First the mean, and then median and standard deviations. So using the PI formula, PI formula is 3 mean minus median divided by standard deviation. You can get your skewness is 0.148. So you can say that the PI is not greater than 1 or less than 1. So it can be concluded that the distribution is not significantly skewed. Okay. And then the third one is you need to check for outliers. So for checking the outliers, using the 5 number summaries, okay, so the first one is you need to find the Q1 value, and then IQI value, and then Q3 value. So the Q1 value is 45, Q3 value is 98, and IQR value is 53. And then check for starting from negative 34.5 until 177.5. So you can say that no data below negative 34.5 and above 177.5. So no outliers. Okay. So from 3 different methods, the first one, construct a histogram, and then check for skewness, and then check for outliers. You can conclude this example with the first one is the histogram is approximately bell-shaped. And then the second one is the data are not significantly skewed. So the histogram is approximately bell-shaped coming from method 1. And then data are not significantly skewed coming from method 2. And then there are no outliers coming from method 3. So that's all for this one. Okay. And then the second way is the central limit theorem. So this central limit theorem is to know how individual data values vary about the mean for a population. So this is the central limit theorem. So in this central limit theorem, there are distribution of sample means. So distributions of sample mean consists of a sampling distribution of sample mean is distributions obtained by using the means computed from random samples of a specific size. And then what is a sampling error? Sampling error is a difference between the sample measure and the corresponding population measure. Yeah? Okay, there are formula for the central limit theorem. As the sample size n increases, the shape of the distribution of the sample means taken with replacement from a population with mean and standard deviation will approach a normal distribution. So the mean of a sample mean is equal to the population mean. Standard deviation of the sample mean is standard error of the mean. Okay. Okay, so this is a formula for Z values. So Z values mean the X minus mean over standard deviation divided by N. Okay, square root of N. Okay, let's take a look on the first example. AC Nielsen reported that children between the ages of 2 and 5 watch an average of 25 hours of television per week. So assume the variable is normally distributed and the standard deviation is 3 hours. If 20 children between the ages of 2 and 5 are randomly selected, find the probability that the mean of the number of hours they watch television will be greater than 26.3. Okay, so the first one is they said that between the ages of 2 and 5, an average of 25 hours. So you can say that we know that the first one is mean is equal to 25. And then standard deviation equal to 3. 20 children referring to n. And then find the probability that the mean of the numbers of hours they watch will be greater than 26. Greater than, and then 26.3 is x. Okay, so the first one, try to draw these normal distributions. When you draw it, they say greater than. So this greater than adds here. So adds here is equal to 26.3. Okay. And then calculate probability for a sample mean. So we need the central limit theorem formula. So this formula is Z equal to X minus with mean over standard deviation divided by square root of N. So X we know that 26.3 minus with 25 divided by standard deviation 3 and then 20 and it is equal to 1.94. Okay. So 1.94 is here. Sorry, here. Equal to 0.9738. Okay. So 0.9738 is actually here. .9738. So we know that this full normal distribution area is equal to 1. So we want to know this area. So take 1 minus with 0.9738. You can get the answer for this area. So this area is equal to 0.0262. So you can say that the probability of obtaining a sample mean larger than 26.3 hours is 2.62%.